Hi, I'm Josh Grossman from the Department of Physics at St. Mary's College of Maryland, and I want to tell you about some work that I've done with Angela Johnson from our Department of Educational Studies. We've developed some interactive websites for student presentations of Get the Facts Out, and then we've modified them and deployed them across every single one of the STEM disciplines at St. Mary's College of Maryland. First, some background on St. Mary's College of Maryland. We're a small public liberal arts college. For students, the most common route to teaching careers is to do a bachelor's in their discipline, plus an educational studies minor, and then to complete our master's of teaching, which is our only graduate program at the college. Angela and I are PIs on a PhysTech recruiting grant, which began this spring, and it's through PhysTech that we learned about all the resources available through Get the Facts Out. When we went to develop Get the Facts Out student presentations for the fall, the pandemic made delivering these presentations difficult. It was hard to get folks together outside of class, yet with the pandemic, class time is really, really hard to get access to as well. Through the PhysTech online learning communities, though, we learned from Sarah Formica at the University of North Georgia that she developed an interactive Get the Facts Out website that she has used there, and so we decided that we would emulate that good model. In thinking about this and preparing it, we realized that there are actually several opportunities here. By making it asynchronous, it can be easier to get it to students during the pandemic, but because it's online and in these saved websites, it's actually easier to present it to multiple groups without having to invest the full time of a presentation for each presentation one gives. We can just resend the web link. It's a lot easier to collect data from an online presentation because one doesn't have to refer students from the live presentation to their devices to input information. They're already on their devices for the website. In the process of preparing the website, we realized it's actually also quite easy to make copies of it and then customize them for multiple disciplines without much extra work and without additional time required to give these additional presentations. One of the things we do is we embed data in the objects, like salary data and stuff like that, in each of the presentations, and so we can push that data and update it all at once across all the different versions. So the programs have all agreed to participate, in part because they recognize the importance of training teachers, but also because they recognize the alignment of this with our professional skills development curriculum across the whole institution. And we also see this as another way to help with recruitment and retention for the institution. Because of this, the dean was happy to also encourage programs. So I created the different versions of the activities for the programs in draft form, shared them with them, and allowed them to do any further customization they wanted to, asking that they continue to allow us access to the presentations and to the data. One of the reasons why we got all the programs to adopt these activities is because we'd actually done most of the work for them. Here we have the website used for physics audiences. You can see that it's just built in Google Sites. What we've done is embedded a Google survey form in the website using iframes. Sarah Formica used Poll Everywhere to embed questions in hers. Either way, what this does is allows us to gather response data in a form that can be exported and analyzed. One of the advantages to this is we can intertwine our questions with the presentations to make it more active participation by the students so they're not just passively playing a video. I'm going to advance straight to the next page. So you can see after the students answer a question, what they see is a display of how other students have also answered that question. Once again, this is embedded using an iframe. It's graphics pulled from a spreadsheet of the survey responses, and it's automatically updated each time someone responds to the survey. So one of the ideas here is that displaying all the students' responses adds to the interactivity, and it gives the students a sense of ownership in the presentation. So I'm going to advance some more. We can see here we're just finding out information about the students, connecting it though to their high school experience, and we're starting to get into some of the Get the Facts Out data and graphics that may look familiar. Eventually, when we get down to questions on facts, so we'll keep going through this some more. Here we're asking about teacher salaries in Maryland specifically. When we get to questions on facts, One of the things that this reveal does is it shows just how widespread some misconceptions are. And the idea is to suggest that other people from whom they're getting information also may have similar misconceptions. So here we can see that a plurality of students have chosen the correct salary range for teachers at different points in their careers, but in fact, a majority have chosen various wrong ranges, underestimating it, and in some cases significantly underestimating it. When we contacted the GFO team, particularly Drew Isola, about this, they were supportive of us in helping us gather this data and also bouncing ideas like this off of them. So we're really appreciative of this. In some of the discussions, some folks on the team were kind of concerned that sharing misconceptions would actually reinforce them. So one of the things we did was we took care to make sure to emphasize that these are misconceptions and here's the correct facts. One of the things we do right here, though, is, again, I mentioned that we can embed this data, and so we can update this data and push it out to all the sites all at once. So one of the things I want to share, though, is an example. Here's the computer science presentation. I've just flipped over to a different tab in my browser, and they've added their own customized data with similar types of messages, but they're not relying solely on the data from Get the Facts Out. I'm going to flip back to the physics presentation, continue to scroll through it. You can see we had 6. This is the 7th page, more data, and then finally, at the end, we gather some self-report data about the extent to which students feel they've learned from the activity and how it changed their level of interest, if it did, in teaching. And then the very final form that we use gathers data that is not anonymous. All the previous data gathering points were anonymous. Clarify that. And at this point, we gather their name, whether they're doing this for credit, and they have an opportunity to request a follow-up conversation with advisors. And then finally, we share the ability for them to go back and review various parts of the presentation, and then also to gather information on our pathways to teaching careers at St. Mary's College of Maryland. This past fall, the physics activity was assigned in 2 different courses, including a 3rd semester course which has weekly career development activities. It was also assigned in a large introductory chemistry course and a pilot calculus section. This coming semester, assigned in all the sections of a large biology course, in a 200-level computer science course, multiple sections in all the sections of calculus, as well as some educational studies sections. Besides gathering individual student data, we also gather information about the overall sets of assignments. Each program has its own spreadsheet in which they log when they assign the activity and various other information about the assignments. A master spreadsheet automatically pulls that log data, and we can report that to GFO for their own purposes. I'm not going to present numerical results at this point because it's so preliminary that we'd like to get a bit more data. But just from this first semester, the self-reports indicate that many students believe they've learned about teaching careers, and many of them actually report increased interest after doing the activities. And the activities have been directly responsible for recruiting prospective physics teachers and prospective teachers from that one calculus section. In the introductory chemistry course, we identified more than half a dozen prospective teachers, but they were all interested primarily in biology because this is an introductory course where there was a mix of majors. When we were talking with the chemistry professors, they alerted us to the fact that they're actually a mix of majors. So we made all the different versions available to them, and we've now done that from a launch page. With that, I want to wrap up and just say that we'd like to thank the entire GFO team, but especially Drew Isola for providing us assistance with gathering Maryland-specific data and for providing feedback on designing these. Also Sarah Formica for the initial idea for the websites. And finally, all the program chairs and instructors at St. Mary's who have deployed these activities in their courses. You're welcome to contact either Angela or me with any questions you may have. And finally, to see the site itself, you're welcome to visit this public version of it that's on the website for our physics teacher education program. Thanks for your attention.